How can anyone be sure lines are parallel if lines go on forever? You and your classmates may be new to geometry, but geometry has existed for thousands of years. And thousands of years ago, Euclid wrote down 5 postulates, one of which is the kernel of the parallel postulate. Let's check it out. What's a postulate? Euclid had many great ideas, but not all could be proven. A postulate is an idea, also called an axiom, that is taken to be true even without proof. Contrast a postulate with a theorem, which is shown to be true by using proofs. What is the parallel postulate? After Euclid knocked out 4 postulates, he waited before springing his 5th postulate, which in an English translation by Thomas Heath states, if a straight line falling on 2 straight lines makes the interior angles on the same side less than 2 right angles, the 2 straight lines, if produced indefinitely, meet on that side on which are the angles less than the 2 right angles. The fastest way to understand the parallel postulate is to set up some line segments using uncooked spaghetti. Take 2 strands and arrange them a bit apart from each other but leaning toward each other. Lay a 3rd strand across the first 2. You see you have created 8 angles at the 2 intersections. Look at the same side interior angles toward the close ends of spaghetti. The sum of both same side interior angles is less than 180 degrees. So, Euclid is saying the lines represented by the first 2 spaghetti strands will, if extended, eventually meet. Let's draw the parallel postulate. Take a sheet of paper, pencil, and straight edge. Draw a short line, perhaps 10 centimeters long. Move away a few centimeters from it and draw another 10-centimeter line. Now, draw a transversal line crossing both of those first 2 lines. If the 2 interior angles on the same side add to less than 180 degrees, the drawn lines will, if they continued, meet. Try it. See if they will meet. Now start again, but this time, draw 2 parallel lines. When you draw in the transversal, the 2 same-side interior angles will either be exactly 90 degrees or will be a combination of an acute and an obtuse angle. For any line and a point not on that line, Euclid shows us that only one line can be constructed through that point that will be parallel to that line. All other lines will eventually intersect with that original line. Euclid's parallel postulate allows that transversal to create many different angles as it cuts across the 2 lines, but it all boils down to only 3 possibilities. The lines are not parallel and 2 same-side interior angles are less than 180 degrees. The lines will eventually meet on that side of the transversal. The lines are not parallel and 2 same-side interior angles are greater than 180 degrees. The lines will never meet on that side of the transversal. The lines are parallel, and any 2 same-side interior angles will be equal to 180 degrees. The lines will never meet. As long as the 2 interior angles on the same side of the transversal are less than 180 degrees, the lines will meet. That allows the transversal to even be at a right angle to one of the lines, with the other line creating an acute angle. Such a situation will create a triangle of the 2 lines and their transversal, which connects directly to the Pythagorean theorem. If you hop over the transversal that created 2 interior angles less than 180 degrees, the other 2 same-side interior angles will always be greater than 180 degrees. No matter the combination of lines, transversals, and same-side interior angles, Euclid's parallel postulate holds true. Only in the special case of parallel lines will a transversal of any angle create 4 interior angles, such that 2 same-side interior angles are equal to 180 degrees.